So what if aging wasn't this, fixed thing? Like not some fate we just have to accept, but a challenge we could actually genuinely address. Imagine adding not just more years to your life, but like more healthy, really vibrant years. Welcome to the deep dive. This is where we take a whole stack of the latest insights, the newest research discoveries, and we really unpack them so you can stay truly well informed. And today we're doing a deep dive into what our research team has pulled together on, well, what we're calling the Immortality Update. The real cutting edge stuff in life prolonging sciences.
Yeah, and it's important right up front to be clear about what we mean. This isn't about, finding some mythical fountain of youth or literal immortality. That's not really the focus. Our focus today is squarely on the exciting, tangible progress being made in extending health span.
Health span. Yep.
That vital period of life where you're actually living in good health, free from those chronic diseases and disabilities that can really impact quality of life. It's about the quality of those extra years.
Exactly. Quality, not just quantity.
Yeah.
So we're going to explore some of these breakthrough interventions, the incredible new tech tools that are speeding everything up, and crucially, the really important ethical questions that pop up with this kind of transformative progress. And I think the big theme, looking at all the information our research team gathered, is this definite shift, wouldn't you say, away from just lab curiosity.
Oh, absolutely.
Towards actual practical medical interventions, things that could genuinely boost health span for potentially millions of people, maybe even within the next, 10 years?
That's the trajectory, it seems. And what's really compelling right now is how our understanding of the core mechanisms of aging is getting so much deeper. That's leading to some genuinely, revolutionary discoveries. For example, a really key finding involves NAD plus MEADS, and it's a vital molecule in our cells. Think of it maybe like a crucial type of cellular fuel.
Okay, like fuel.
Yeah, and its levels naturally drop off as we get older. Now, this decline, it's been strongly linked to a whole host of age-related problems. But specifically, it seems to impact how well immune cell therapies work, especially in older patients.
Ah, okay. So the treatment doesn't work as well because the body's NAD plus is low. But here's where it gets really exciting, right? The news you mentioned.
Exactly. The really exciting part is that restoring those NAD plus levels has been shown to, deeply rejuvenate aged immune cells.
Rejuvenate them, like actually make them younger acting.
Pretty much. Imagine these immune cells sort of worn down by age, suddenly getting their youthful vigor back. They've even seen enhanced ability to fight tumors more effectively in some studies.
Wow.
So it's not just making cells feel younger, it's like giving them back their original punch.
That's amazing. So are we talking about actual measurable changes here?
Oh, absolutely. Measurable improvements in how these aged immune cells behave. Things like enhanced mitochondrial function, basically boosting their internal powerhouses, and even improving their stem-like properties, their ability to renew themselves.
Right.
And what makes this so impactful, so exciting, is that this research seems really poised for clinical translation, like moving into human trials.
How soon are we talking?
Well, the research suggests we might anticipate human trials for NAD plus supplementation interventions kicking off possibly as early as late 2025.
That's really soon.
It is, and it's partly because NAD plus already has a pretty strong safety profile from earlier human studies. It suggests a potentially rapid path from this promising research to, widespread potential benefit.
Okay, that sounds like a huge leap forward. Now, let's shift gears slightly. Let's talk about something we've touched on before. Senescent cells. Those zombie cells, as they're often called.
Right, the zombie cell.
Yeah. For a while, the basic idea was pretty simple, right? They stop dividing, they hang around, they cause inflammation, contribute to aging. Basically, just bad news.
That was definitely the common narrative, get rid of them. But the information our research team compiled, it paints a far more complex picture. They've actually identified a newly recognized subset of human immune cells, specifically, naive T cells that look senescent. They show signs like DNA damage.
Okay, the usual signs.
Exactly. But here's the twist. They surprisingly retain a robust ability to proliferate, to divide, and multiply.
Huh. So they look old, but can still act young in some ways.
Sort of. It suggests maybe it's more of a stress-adapted senescent-like state rather than just being uniformly detrimental zombie cells that need clearing out. It's like finding a senior citizen who looks their age but is still running marathons,
Okay, that changes things quite a bit. So the old strategy of just like carpet bombing all these senescent cells might actually be throwing out the baby with the bathwater for some of them.
It could be, yeah. This deeper understanding really means that future therapeutic strategies might need to evolve, maybe moving beyond just eliminating these cells entirely.
Towards what then?
Well, perhaps the focus could shift towards, say, reprogramming them, or modulating their function, or even restoring some critical cellular processes within them. Basically, trying to combat that age-associated immune dysfunction and chronic inflammation in a much more targeted way.
More precision.
Exactly. A much more precise and sophisticated approach to intervening in the aging process.
And are we seeing any practical results from targeting senescent cells, even with the older clearing out approach?
Yes, actually. Beyond this new understanding, the research team's findings do highlight some practical applications emerging. There have been early pilot trials using senolytic drugs. Those are the compounds designed to clear out some types of senescent cells. And they've shown some promising results in people considered at risk for Alzheimer's disease.
Really? What kind of results?
Well, participants actually showed improvements in things like cognitive scores and physical function. Plus, they saw reductions in inflammatory markers in the blood.
That's significant. Real-world impact.
It is. And now larger, more controlled trials are underway to really confirm these functional gains. So, yeah, even with the evolving understanding, there's definitely progress on the application front.
Okay, this is fascinating. But all this rapid progress, it isn't just happening because of new biological insights, right? It's also being fueled by some incredible new tools and technologies.
Oh, absolutely. Technology is a huge driver here.
We're moving beyond just, counting the candles on your birthday cake or chronological age to really understanding your biological age, how old your body acts. And the research team highlighted some remarkable advancements in tools to measure this.
Yes, that's a key area. One major development is something called the HealthSpan Proteomic Score, or HPS.
HPS, okay.
It's a blood test. It measures the levels of 86 different proteins to predict how long someone is likely to live in good health.
Ah, so focused on the health span again.
Exactly. It apparently outperforms many existing biological age measures because it's specifically designed to gauge those years of healthy life, not just overall lifespan.
And that could speed up research too, right? You mentioned something about surrogate endpoints.
Precisely. What's really exciting from a research perspective is that the HPS could potentially serve as a surrogate endpoint in clinical trials.
Meaning
Researchers wouldn't necessarily have to wait decades, tracking people until the end of their lives to see if an anti-aging therapy worked. They could potentially see if the therapy improved the HPS score much, much faster. That could dramatically accelerate the development of new treatments.
that makes total sense, a real game changer for trials. And there was another clock mentioned, the Intrinsic Capacity Clock.
Yes, the IC clock, another really interesting one. Also a blood test, but this one's an epigenetic clock. Think of it like a biological odometer measuring wear and tear at the DNA level.
Epigenetic, so it looks at how genes are switched on or off.
Kind of, yeah. It looks at patterns of chemical tags on DNA that change with age, and it estimates your intrinsic capacity, which is basically a sum of how well your body's core systems are holding up.
Which systems?
The research highlights 6 key functions crucial for healthy aging. Things like mobility, cognition, mental health, vision, hearing, and even nutrition and vitality.
Wow, that's comprehensive.
It is, and it's proven to be a pretty strong predictor of overall mortality. Plus, it's linked to better immune performance. So yeah, these biomarkers, the HPS, the IC clock, they are truly revolutionary for letting researchers quickly assess if an anti-aging therapy is actually working.
And it's not just about measuring age, is it? Artificial intelligence seems to be popping up everywhere in this field, too.
Oh, AI is huge. It's rapidly transforming longevity research across the board, really, from the initial basic science discovery all the way to practical healthcare solutions. It's definitely way beyond just being a buzzword here.
How is it being used in practice?
Well, one fascinating area is using AI to optimize health and caregiving. There's this concept called responsive care technology.
Responsive care technology.
Yeah, it uses AI and sensors and things like that to promote autonomy, safety, and connection for older adults. I'm talking about things like remote monitoring, even AI-assisted medication management.
So helping people live independently for longer, safely.
Exactly. The wider implication is a future where AI actively supports independent living, offering really tangible benefits for individual well-being and potentially reducing caregiver burden too.
That sounds incredibly useful. Any other surprising AI applications?
Well, yeah, in a truly innovative, maybe slightly sci-fi sounding application, AI is being explored for its predictive capabilities. There are new methods using visual data like facial scans or whole-body images.
Pictures.
Yeah, pictures. Leveraging AI to analyze these images to estimate remaining lifespan with apparently state-of-the-art accuracy.
Whoa, estimating lifespan from a photo. That's intense.
Well, it is. But imagine the potential for very early risk assessment and developing proactive health strategies based on that visual biomarker data.
Okay, my mind is slightly blown. What about clinical trials? Is AI helping there too?
Definitely. Platforms are emerging. The research mentioned the Mayo Clinic's platform as an example that leverage AI and huge data sets to enable the creation of synthetic placebo arms.
Synthetic placebo arms, what does that mean?
It means instead of needing a large group of people taking a placebo for comparison, they can use AI and existing data to simulate what would likely happen in a placebo group.
So you wouldn't need as many people in the actual trial.
Potentially, yes. Or you could make trials faster, maybe more affordable, perhaps even more inclusive, by reducing the need for participants in the placebo group. It could fundamentally reshape how longevity interventions are researched and validated.
Faster, cheaper, more inclusive trials. That sounds incredibly powerful for getting these therapies out there.
It really does. And looking ahead, the expectation is that AI will play an even bigger role in what's being called precision gerontology.
Precision gerontology. Like precision medicine.
Exactly like that.
Yeah.
Assisting doctors in personalizing anti-aging treatments based on your specific individual genetic makeup, your biomarker profile, your lifestyle data. Moving away from a one-size-fits-all approach to aging interventions, it's about tailoring treatments just for you.
Okay, this is moving so fast. And for everyone listening, if you're finding this deep dive insightful and want to keep up with these kinds of future-focused topics, please do take a moment to like this video. If you're on YouTube, subscribe to Tomorrow Unveiled, and definitely hit that notification bell so you don't miss our updates.
Yeah, and if you're listening on a podcast service, perhaps Apple Podcasts or Spotify, we'd be incredibly grateful if you could leave us a rating and maybe a quick review. It genuinely helps us reach new listeners interested in this stuff.
Okay, so we've got these incredible biological breakthroughs like NAD+, and the nuanced view of senescent cells. We've got these powerful new tools like advanced biomarkers and AI. But all this amazing progress inevitably brings us to the broader picture. The ethical side, the societal considerations.
Which are hugely important.
Absolutely. The research our team looked at really emphasizes that, as exciting as these breakthroughs are, many of the more dramatic life extension strategies, things like bespoke gene therapies, maybe advanced plasma exchanges, that kind of thing, they're still very experimental, and they carry inherent risks. High risks, potentially.
That's a critical point to underscore. These interventions often involve modifying really fundamental biological processes. That means we absolutely have to watch out for unintended long-term consequences. We just don't know everything yet.
So regulation becomes key.
Absolutely critical. It highlights the need for robust regulatory oversight, really careful phased clinical trials to ensure safety before any kind of widespread use. It's that constant balancing act, isn't it? Pushing the scientific boundaries while ensuring absolute safety for people.
And there's the hype factor too, right? We need to guard against false hope and just pure hype.
Yes. The information compiled included some cautionary tales, like recent findings around the supplement taurine. For a while, it was really hyped up as a potential anti-aging elixir based on some animal studies.
I remember seeing headlines about that.
Yeah, but then more rigorous studies came out looking in humans, and they found, well, no clear relationship between taurine levels and aging in people.
So the hype got ahead of the evidence.
Exactly. It just underscores that extraordinary claims really do require extraordinary evidence. We need that solid proof from well-controlled human trials before jumping on the bandwagon for any new intervention. Caution is definitely needed.
That leads really naturally into the next big question, accessibility and equity.
Yeah, who gets this stuff?
Right. The analysis from the research team flags major concerns about who will actually have access to these cutting-edge therapies, especially early on.
Because they'll likely be expensive.
Extremely expensive, potentially. Things like bespoke gene therapies or advanced infusions. That risks widening the already existing health disparities, doesn't it? Creating a kind of two-tiered system where, extended health span becomes a luxury item only for the wealthy.
That's a really stark possibility, and one we have to actively work against. The goal, as highlighted in the research we reviewed, absolutely must be to ensure that proven anti-aging therapies, once they are proven safe and effective, become affordable and widely available, globally, ideally.
Are there any positive signs on that front?
Well, it's early days, but it's inspiring to see initiatives thinking about this. The research mentioned, for example, the UK's accelerated clinical trial infrastructure. Part of its design is specifically to try and create pathways for more equitable access to new interventions once they're approved. So people are thinking about it.
That's good to hear. But beyond individual access, there are even bigger societal questions, aren't there?
Oh yeah, the really big picture stuff.
Our information points to the need to really consider the broader societal implications if we actually succeed in significantly extending health span for millions, maybe billions of people.
What happens then?
Right. Could it lead to unforeseen strains on global resources, water, food, energy? Could it disrupt existing family structures? What does it mean for inheritance, for caregiving roles? And the economic implications are profound. Like, how will retirement ages need to adapt if people are healthy and productive into their 80s or 90s or beyond?
These are massive questions, not just scientific ones, but deeply societal, ethical, philosophical questions.
Yeah.
And the field itself, the researchers involved, they seem to recognize an obligation here, an obligation to anticipate and try to mitigate these potential negative consequences.
So it's not just full steam ahead, damn the torpedoes.
Hopefully not. The consensus seems to be calling for open, thoughtful, really inclusive public discussions to shape the ethical framework within which these advancements take place. The goal has to be ensuring that this pursuit of longevity truly enhances human well-being broadly, for everyone, not just for a select few.
Wow. Okay, what a deep dive that was.
Yeah.
We've covered a lot of ground. It seems really clear that the field of longevity science is incredibly dynamic, moving super fast, and it's definitely shifting its focus.
Yeah, definitely. Away from just prolonging life, any kind of life, towards deeply enhancing our health span, making those later years good years.
We've uncovered a deeper, more nuanced understanding of some key aging mechanisms, like with NAD+ and senescent cells. We've seen the transformative power of new technologies, AI, these amazing biomarkers, and we've really acknowledged the crucial ethical responsibility that comes hand in hand with these breakthroughs.
And just to reiterate, this isn't about chasing some fantasy of literal immortality. I think the ultimate vision emerging from the research findings is actually something perhaps even more meaningful. Adding life to years. Making sure that our increased lifespans, which are already happening to some extent, are matched by an enhanced quality of life. That seems to be the real prize. The developments discussed today really underscore that functional longevity, living well for longer, is becoming, potentially, an achievable reality for a much broader population. It promises a future where more of us can live independently, productively, vibrantly, for much longer periods.
So, okay, we've explored the science, the tech, the ethics of extending health span, but now the question kind of turns to you, the listener. What does a future with dramatically extended healthy lives actually mean for your personal plans, for your career path, or even for the very fabric of society as we know it? How might we all start preparing for a world where old age looks fundamentally different than it does today?
Yeah, that's the big takeaway thought. And we genuinely love hearing your thoughts on this stuff. So whether you're watching on YouTube or listening on your favorite podcast app, please do leave a comment. Let us know what you think about this immortality update and the future of HealthSpan.